Hello, we are going to talk about global climate change, which is topic 9.5, and honestly, it goes throughout the entire class all year long. We'll be talking about climate change. So, this is obviously super important to have an understanding of this topic. So, we should be aware of the fact that climate does indeed change over time. Earth's climate, it has always been in some sort of fluctuation. It has not been the same for all, 4.5 billion years that the planet has been around. Sometimes climate can change drastically over a long period of time. Sometimes it can change drastically over a short period of time. What we are mostly going to focus on here is how climate has changed over a short period of time. But I do want you to understand that the climate can also change over, we're talking long term, millions of years. What is important to note are the trends, the patterns that we see. And we'll talk about some of those patterns when I show you a couple of graphs. You can get on Google and type in Keeling curve, and I'm going to show it to you here on the slideshow anyway. The Keeling curve is a great way to look at how carbon dioxide, which is a major greenhouse gas, how that carbon dioxide concentration has changed over the years. And let's look at some of those graphs right now of a Keeling curve. Here we go. Nope, just kidding. Here we go. So we are on this particular graph looking at a couple of different things. Anytime you're looking at a graph, look at your axes first. So your x-axis or your horizontal axis is showing how long ago, or date, whatever you want to refer to it as. And then your y or your vertical axis is referring to carbon dioxide concentration in parts per million. Parts per million is a pretty generic term. What it refers to is for every million parts of molecules in the air, or every million molecules in the air, certain number are going to be carbon dioxide, and that number is the part. So that's what we're looking at on this particular graph, and you can see there are fluctuations, all of these peaks, and then carbon dioxide goes down and it goes up. And so my point on this graph is that carbon dioxide concentrations have varied in the past. But what you should take note of, and it got cut off. What you should take note of, let me pull up the website. Hold on, I'm going to pause it. Okay, we're on the Keeling website now because my picture got cut off on PowerPoint and I didn't notice it. So what I want you to notice, aside from the ups and downs, and that was, natural variation in carbon dioxide concentration, notice at the 0 mark here on the x-axis, we're talking present day, look at how this line it's vertical. It's not even like exponential J-shaped growth. That is vertical. And so that is what we are concerned about, is this drastic, rapid increase in carbon dioxide concentration over a very short amount of time. Technically, it's pretty much since the Industrial Revolution began, which was in the 1800s. And with the Industrial Revolution, we began burning fossil fuels like coal, oil, and natural gas. And when we burn fossil fuels, they release greenhouse gases. And that's what we're seeing with this vertical line here, is this drastic increase in carbon dioxide concentration in a very, very short amount of time. That is what should be concerning to all of us. We have never seen such a rapid increase in carbon dioxide concentration ever before. And that is attributed to humans and the things that we do that release carbon dioxide. So, again, the main point of this graph is to show you, yes, CO2 concentrations have cycled over the years. But what we want to focus on is that very short time frame down over here in present day, where CO2 concentrations are now at points that we have never seen before. So I just wanted you to see that. Yeah, definitely cut off here. Wanted you to see that on this particular graph. Here's another one. Again, let me go back to the website. Hold on. In case something else got cut off. Not that one. Yes, this one. So on this one, the 1700s to present day. Your x-axis is your time or date. Your y-axis is still your CO2 concentration. So CO2 has remained, relatively stable until about the time of the Industrial Revolution, when things started changing a lot. And then, things really took off in the 1900s, and we get this rapid increase in CO2 concentration. That's what we're emphasizing. If we look at the full record, this is a favorite graph that College Board likes to use often. This is 1960 to present day. You can see full record ending September 12th. Today is September 12th, 2024. So again, x-axis has the years, y-axis has your CO2 concentration. The data is collected in Hawaii at an observatory up at the top of a mountain, of a volcanic mountain, at Mauna Lea. There was a couple of years, you can just make it out in blue right here, where data was collected at a different observatory, still in Hawaii, because Mauna Loa was, there was a volcano erupting nearby. So they had to switch locations. But anyway, what I want to point out on here, again, is that steady increase in carbon dioxide concentration. Look at it in terms of, we'll say, my life, where I was born in the late 1970s. And so our CO2 concentration, we'll say, was about 330 parts per million. And now present day, we are at 420 something, 422, 425. It varies day to day. So that's a big increase in just 40 something years. And that is what we are concerned with, is how quickly CO2 concentrations and other greenhouse gases, how quickly they are increasing. What College Board likes to point out on this particular graph is that fluctuation. You can see that there are high points for every year and also low points. So the graph is going up and down, up and down, up and down. And I would definitely recommend that you understand why that happens. And it's basically a function of seasons. If you think about it, excuse me. In the spring and summer months is when you have lots of plants that are, photosynthesizing. And when plants are photosynthesizing, lots of leaves on the trees and stuff like that, they are taking in carbon dioxide from the atmosphere. So plants are removing carbon dioxide from the atmosphere. And that means in the summer months, that's when you have these low points, kind of in this blue area. And then in the winter months, when trees kind of go, I don't want to say dormant, but trees drop their leaves and there's not as much photosynthesis taking place, which means there's more CO2 in the atmosphere. That's when you have these high points. And so, again, College Board likes to ask about that. And the reason why we have that up and down for every year is due to seasonal plant activity. The more plants we have and the more photosynthesis that is happening, the more CO2 will be taken out of the atmosphere and you'll get those low numbers. So that's the Keeling curve. So, you could go, again, I'll go back to the Keeling curve for a second. Like, how do we know what, no, I don't like that. How do we know what things have looked like, 800,000 years ago when there clearly were no humans around 800,000 years ago? So how are we able to know how much carbon dioxide there was in the atmosphere? Well, we use something, hold on. Nope. We use something called proxy data. The word proxy, not just a science term, but it means kind of using other things, other people. You could have somebody act as your proxy and sign something for you. So a proxy is a tool that we can use, not a physical tool, but something we can use to get an idea of what the climate was 700,000 years ago, because clearly there was no measurements taking place back then. So some examples of proxy measurements that we use. Isotopes. For example, there is an isotope of oxygen called oxygen-18. So we can measure the amount of that isotope, and what we can see when we measure it in rocks or whatever. If we have an abundance of oxygen-18, that indicates to us that there was warmer climate. Oxygen-18 is predominant in warmer climates. So that is an example of a proxy. How are we figuring out what did the climate look like hundreds of thousands of years ago? We can look at pollen. Different types of trees do better in warm conditions. Other types of trees might do better in cooler conditions. Pollen can kind of get stuck in the ground and fossilized and trapped in amber. And so we can look at pollen and get an idea. All right, this kind of pollen came from this tree. We know that these trees thrive in warmer environments. So that must be an indicator that the environment was warm back at this time. We can look at ice core data, basically drilling down into an ice sheet or a glacier. And we can extract a tube of ice or a core of ice. And in that ice core, we can look at little air bubbles or gas bubbles that are trapped when the ice is formed. And we can look at the different gases that were present. You know, was there a lot of greenhouse gases? If there were a lot of greenhouse gases, climate was probably warmer. So ice core data is something great for reconstructing past climate. We can look at tree rings. And, you know, when you look at a tree ring, you can figure out the age of the tree. You can learn about how much moisture there was. So tree rings are a way to learn about past climate. We can look at a type of plankton called a foraminifera, or foraminiferans, or forams. And forams are kind of cool because they have little shells that stick around after the organism dies. And the shell is built in a spiral. And it grows either like a clockwise spiral or a counterclockwise spiral, depending on the temperature. And that's what you see here. That little right kind of clockwise spiral indicates warm water. A counterclockwise or left spiral here indicates colder water. So all of these together are proxy indicators. And again, proxy means like approximation. These are telling us a story and telling us what the climate was like, because again, we didn't have any humans around hundreds of thousands of years ago. So we have to use these proxy indicators to figure out what the climate was like. And that's how we are able to build, you know, a graph that looks like this. So that was the beginning of 9.5 and global climate change. Make sure you know the Keeling curve and the different variations of it. And we're going to come back in a second video and talk about impacts of climate change. If you have any questions about anything I mentioned here, let me know. Bye.